everyone, welcome back to my YouTube channel. In this particular video, we'll be looking into the DSPy framework. Basically, we'll be looking into an introduction to this particular framework, DSPy. Obviously, before starting the video, I would like to specify what exactly it is. So, let's not waste much time and dive into the details of this. So, first, we'll look at the definition. The definition says DSPy, it stands for Declarative Self-Improving Python, which is a framework for programming rather than prompting the language models. Now, when we talk about language models, prompting for sure comes. And yes, language model requires prompt. But as a human, till what extent we will be writing prompts? We might make errors. There might be some statements that we might miss out. So we have to look for multiple scenarios to restrict the large language model for a particular use case. We'll have to mention all the restrictions, all the things, what to do, what not to do in a prompt. We cannot create a generalized prompt which will be helpful for every single use case. Each use case will be requiring different prompts. Also, when we talk about language models, every single language model has its own version of language that it understands. If I want to explain a single sentence to a large language model, let's say Llama 3, and the Llama 3 understands it nicely. The same sentence, if I pass it on to GPT-4, there might be a case that the arrangement of the words might not be understood by that GPT-4 model. It might require me to add the prompt in some other way. Some language model requires straightforward words. Some language model understands straightforward arrangement of words or sequences, while others might not understand it. It might require the details of it. So as we change language models, we'll have to alter the prompt. We'll have to write it from scratch. So the developers of this DSPy framework came with an idea of ruling out prompting the language models. Instead, why not we program the prompt? Why not we make a flow in such a way that the prompt will alter itself according to the situation, according to the query, according to the language model? So this DSPy helps in doing all this. It believes in prompt programming rather than prompt engineering. So the manual work of any prompt engineer will drastically reduce. Also, while writing prompt, we have to look for multiple scenarios. For example, the input format, the output format in which the large language model will provide our output. Everything has to be considered. But using this framework, we don't have to worry about all that. This framework will solely handle everything. So this is what is depicted from the definition that this framework has. Now, it allows you to iterate fast on building modular AI systems and offers algorithms for optimizing their prompts and weights. Whether you are building simple classifiers or sophisticated rack pipelines or agent loops. So, for any kind of project, whether it is a simple one or a complex one, it will make it automated. This DSPy framework will make it automated. What magic it does? It simply optimizes the prompt and the weights of the large language model in a way that the model understands it better and will try to minimize the error. Just like neural networks, if you are aware of neural networks, it trains itself, tries to increase the accuracy, minimizing the loss. Doesn't that sound amazing? Let's now see the components of this particular framework. So here is the list of components that I have provided. I have provided here 10 components of DSPy. We'll be looking into the definitions of it one by one, but in detail we'll be looking into all of them in the upcoming videos. So the very first and the most important component in DSPy framework is the modules. Now what exactly it is? You can call it as the building blocks for programs using the large language models. It abstracts prompting techniques like chain of thought or React. Next, we have the signatures. Again, it is important. It is declarative specs defining the behavior of modules. Whatever module or class you define, this signatures will define the behavior of your module, how your module has to behave. Next we have is optimizers. Again, it is very much important. It is actually a tool for tuning the prompts and weights, aligning the large language model with program structure and matrix. It is used for tuning the weights, increase the accuracy, minimizing the loss. Next component is the examples. Now, what exactly it is? It is the core data type for representing the training and test data, which is similar to Python dictionaries. So, in examples, we usually provide the question answer set on which we have to train our large language model, or I would say on which we have to train our prompt or optimize our prompt. We can also have this golden data set created so that we can evaluate it as and when we optimize or tune our prompt. Next is the retrieval model. It is similar to your retrieval for your vector DB. It is basically an interface for integrating the retrieval systems like Colbert V2 and Milvus. Next we have is evaluation. This evaluation is a method for accessing the model performance using the metrics like semantic F1. There are other metrics also. We'll be looking into all of them. Next, we have assertions. It is basically a mechanism for ensuring programs correctness and the improvement of reliability. Next, we have adapters, which acts as a translators between signatures and the LM interfaces. Next is the fine tuning, which is again an important component. It's nothing but the process for optimizing the LM weights, which enhances the model performance on specific task. And finally, we have the community and ecosystem, with nothing but an open source contribution advancing the AI research and application development. So here we have all the components of DSPy framework. I hope you must have got a basic simple idea about all of them. We just have seen the definition. We'll be exploring it in detail in the upcoming videos, so stay tuned for that. So you can see this is the documentation page of DSPy framework. I'll be providing you the link to this particular website in the description box, so check out that. So you can see in the learning modules, we have the DSPy programming, evaluation, optimization, references. Under programming, you can see a lot of things comes like signatures, modules, language models, how we can access it. Then under the evaluation comes the overview, data handling, matrix. Then under the optimization comes the optimizers, which is very important. And in your free time, you can obviously read their documentation. It is very beautifully written. You can also check out their GitHub repo over here. It is an open source contribution made by Stanford. You can see the entire code over here. Let's not waste much time and dive into the code so that we can have an understanding how we can access large language model and how we can use it with the help of simple signatures and the modules. So there is a package of DSPy which is called as DSPy-AI. So you will have to install it using this command, and once you are installed with it, you can access their libraries. So we'll simply import DSPy. Let's execute this. If you face any errors, then you can straight away put it in the comment section. Now first we'll be looking into how we can access any large language model from any website. For example, if we are accessing the large language model from Hugging Face or from Grok AI. And finally, I'll tell you if you want to access the large language model from any source, then how you can use it or how you can access it. So first we'll be looking into how we can access the large language model in DSPy framework from the Grok AI. If you guys don't have any idea about Grok AI, what exactly it is, then I already have published a video on it in the generative AI playlist. You can have a look at it from my channel. Make sure that you have an active API key on your Grok API. We'll define a variable named LM, which will store the large language model. So we have a function under the DSPy, which is nothing but LM. You can see this DSPy has multiple such classes, functionalities, so you can have a look at it. For now, for accessing the LLM from Grok AI, we'll be using this LM module. Now what I'll do is inside this, I'll simply pass in the path to that particular Grok. So basically the name of the model is Llama 3.170 billion versatile, and next we have to also provide the provider from where you are accessing this particular model. Since we are accessing it from Grok, you have to write the provider as Grok. Now, how you can get the name of the provider, the exact name of the provider, I'll tell you in a moment. Next, we have to specify the API key for this particular grok. So I already have configured the API key in my environment, so I'll just access it. So let's execute this. And yes, it has got executed successfully. Now, once the object is ready in which you have stored your large language model, then you can simply configure it with the help of DSPy.configure. And inside this, you have to simply pass on the parameter LM, which is nothing but the variable in which we have stored the language model now. So let's configure it, and it has got configured. Now, to check whether it works or not, we'll simply pass on a simple message inside the LM. So let's execute this. It should produce output for it. Cool. So it has produced the output. That means our language model is getting accessed correctly. There is no error. Now, this is one way of configuring the LLM with the help of the Grok AI. What if we want to access the LLM from Hugging Face? So in that case, you just have to change this particular path to that particular Hugging Face model and the key. Over here, it will be the Hugging Face tokens that you create to access any model from Hugging Face. So I have a code for it. Let me show you that. So you can see over here the code. What I have done over here is I have simply pasted the path to the Hugging Face model. Here we are using the Llama 3 8 billion instruct. Look, here the provider is Hugging Face and from the Meta Llama is the path. And I'm sure that if you have followed my videos regularly, then in that case you must have an idea that how you can get the path to Hugging Face model. If not, then please check out my earlier videos. And then I also have provided over here the API key for Hugging Face. That means the HF token. I have already configured it in the variable. Let's execute this. And you can see it has got executed. Now we'll also try to get the response from this Hugging Face model, whether it is accessible or not. Let's see. So here we'll use the object lm underscore hf. Let's execute this. Now cool, you can see this. We are getting the result. That means we can easily access the large language model from any source if we have the API key and we know the provider and the proper path. So if you just make any mistake in this provider, it will throw you an error. So let's say we just make a mistake in the spelling. Instead of writing Hugging Face, we have written FAC. I'll just execute this. Let's execute this. So now you will be getting an error over here. See, passing the LLM provider you are trying to call. Now with this error, they also have thrown this particular documentation, which is nothing but docs.lightllm.ai. So you can just click on this, and this is the provider list of all the sources from where you can access the large language model. OpenAI text completion, Azure OpenAI, Gemini, Anthropic, Mixtral, then Hugging Face. So you can just have a look at your source. So let's say I want to access the API, the language model from Grok. So I'll simply click on Grok, and here you can see we have got the provider name. Similarly, if you want to access it from Hugging Face and if you want to know the provider name, just click on Hugging Face and here you can get the provider. Cool. Let me show you for Azure OpenAI. Here you can easily see the provider name is Azure. So I hope you are understanding what I am trying to convey. So now that we have configured our language model using DSPy.configure, here for now we have configured the Grok language model, which is nothing but the Llama 3.1 70 billion versatile. So I'll simply use this particular language model, and now we'll be looking into basic terminologies of using DSPy. We'll look into a basic idea about signatures and modules. To access the DSPy module, what you need to do? You have to call DSPy dot. Now inside this, whatever you see over here is nothing but the module. Here you can see there is a module named as predict. Now as I said that for every module you define, you have to define a signature for it. So first let me tell you what exactly this predict module is. This is the root module, I would say. This is the most basic module in DSPy, which is used for predicting the output. Whatever input you give, let it be a query, let it be any sequence, this predict module will generate the output for it. So now what I'll do is we'll simply pass on a signature for it. Now signature defines the behavior of this particular module. Now a signature can be defined inside this in the form of a string. Note, what we have to do, we have to write here. The motive for using this particular module is just to pass on a question and we'll get an answer for it. So what I'll do is I'll simply write question and then an arrow. Make sure about this, it's an arrow, a hyphen, and greater than. Next I'll simply write answer. Now what this signifies, we have an input which is named as question and we have the output for it which is named as answer. Now just be careful, whatever you write here is nothing but the exact variable that the DSPy will interpret. So make sure whatever you write here has to be meaningful. So it will take a question and it will generate an answer for it. You can also define the data type for it. Now my question will be a string. Similarly, over here my answer will also be a string. Now if you want the answer to be a numeric, then you can simply define int or so on. Now as we are defining this, we have to store it in a variable. We'll have to create an object for it. So let's say the name of the variable in which we are going to store this is going to be generate. So now what I'll do is I have the variable. I can simply access this by passing on the question inside it. So what I'll do is I'll write generate. Now inside this, I'll pass on a parameter named question. Let me write this. Let's take a question. Say our question is what is the capital of India? This is my question. Now here you need to make sure that whatever you write here, the same will be acting as a variable name. So if I write anything instead of question over here, then it will simply throw an error. Let's store this in a variable named response and let's execute this. Cool. We have got it. Now let's check our response. Now you can see over here the response that we are getting is of the type prediction object, inside which we have a parameter, or I would say the variable answer, in which we have got this. So if you only want to extract the answer, then you can simply write dot answer over here. So whatever you define the name over here, that will be kept as a parameter inside it. See, we have got it. Now if I try to write any other thing instead of question, let's say I write query over here and let's execute this. See, it is throwing an error that the expected value was supposed to be a question but got query. So we have to be careful while passing on the names. So this is also very significant. Whatever data type you pass over here, it has to be strictly in that format only, because this DSPy is very sensitive to whatever you define as a signature. So if I write the answer in the form of an integer, if I expect the answer in the form of an integer and I pass it on a question, what is the capital of India? Obviously, the answer to it would be a string. But since we have defined integer over here, let's see what we get. See, we have got 0. So you need to be careful about what you write in signature. So I hope this thing is clear now. Similarly, we'll be defining one more signature. This time, what we'll do is generate the rephrased query of the inputted query, which might be of wrong spelling, which might be containing wrong grammar. So I want the rephrased query of the inputted query. So for that, you don't have to do much. Let's just define a new variable. Let's say generate query. It will take a question and it has to return a question only. But I'll define the name as rephrased question. By just defining this, it will understand what exactly it has to do. Let's see whether it understands. I'll simply write the name here. Let's execute this and let's print the response. See, it has rephrased the query and how beautifully it has done that. So let's try for another one. If x plus y gives 10, then what is x? Then in this case, let's see what we get. See, it has properly rephrased it. So you can see how beautifully it works. Now let me show you in the backend what exactly it does. Here you can see we have used the Llama 3.170 billion parameter model, and as you know, Llama 3.1 requires its prompt template to generate the answer properly. But here we only have defined this simple signature. Only because of this it is creating answer. How wonderful it is. You can just imagine the power of it. Let me show you in the backend what exactly is happening. So now if I try to copy this, and now if I try to show you what exactly is this, let's print it. You can see this. It is nothing but a predict object inside which there is a signature. You can see as it is, the signature has got printed over here, and the instructions are. Now DSPy framework automatically defines these instructions. Given the fields question, produce the field rephrased question. Also along with that, it has declared the type of whatever input is going to be coming to it. So this is how the DSPy works. At the backend, it automatically writes the instructions. Let me show you the inspect history. So there is a module named as inspect history. Let me show you that. Let's try to inspect the history. Yeah. So this is the recent call that we have made. That is nothing but this one. If x plus 5 gives this, then what is x? So let's see how it works. First, you can see the system message is something like this. Your input fields are the question, your output fields are the rephrased question. This is the prompt, okay, that DSPy has automatically written at the backend. All interactions will be structured in the following way with the appropriate values filled in. You can see the input variable is passed on over here, the output variable is passed on. Then here additional instruction. In adhering to the structure, your objective is, given the fields this, produce the field this. Then the user message is also given over here. Respond with the corresponding output field, starting with the field rephrased question and then ending with the marker for completed. So these delimiters also it properly automatically puts. And you can see the response that it has got is this. So all these things are done automatically at the backend. So with the help of inspect history, you can just have a look at what exactly is happening in the backend. Let me show you one more module, DSPy dot chain of thought. Now I already have explained you what exactly chain of thought is. We have written a prompt for it from scratch. If you haven't watched that yet, please go to the generative AI playlist on my channel and watch it. Now here, we don't have to worry about the custom prompt. We just have to import the module and we have to write the signature for it. Now what we'll do is, we'll simply define the same signature whatever we have written over here, and we'll pass on to it the chain of thought module like this, and let's store it in a variable, say cot. Let's execute this, and now if I show you the cot, you can see over here it has taken the signature, but this time with the rephrased question as an output. It also has given the signature, it also has given the variable reasoning, because chain of thought works on the phenomena of reasoning only. It automatically defines this. The instructions are given like this: the question, the reasoning, and the rephrased question. All these variable are automatically defined by itself. Now let's try to check how it works. So we'll define a question inside it. So let's say the question is, what is 2 plus 2? Now in this case, you can see what response we are getting. The rephrased question for this is, what is the sum of 2 and 2? It properly works here. Next, along with this rephrased question, we also have got the reasoning parameter as an output. The question is a simple arithmetic operation and the goal is to rephrase it while maintaining the original query and so on. You can see how wonderfully it works. We don't have to define any instruction, only use the module, and that's it. Now, no doubt you can customize all this module from scratch. You can do that. Whatever module you can see over here, chain of thought, you can customize it what the way you want. You can create your own module also. and we are going to look into this in the upcoming videos. So I hope by looking at this particular introduction code, you might be excited for the upcoming videos. So please stay tuned for it. So I hope whatever is explained till now is clear to you all. If you guys have any single doubt, then you can straight away put it in the comment section. I'll be happy to solve it. For more such videos, do like, share, and subscribe to my channel. Also hit the bell icon and don't forget to follow me on Instagram. Please join me on Telegram. Thanks for watching. Have a good day ahead.